But since you got up out of bed this morning, we're going to reward you with some really interesting and cool stuff. We're going to hear presentations on matters related to non-web identity, but also matters related to web identity. I have 3 presentations, one on but they're all sort of on sort of the same underlying technology, OAuth. I guess if these balloons are here, nobody can see anyone who's actually standing here, but never mind. We're going to get 3 presentations that are basically about OAuth, but in sort of different form, shapes, and sizes, and different applications of OAuth. We're going to start with Francois Kuhlmann, who's from Surfnet, who's going to talk to us about OAuth proper, and then Roland is going to talk to us. Andreas then is going to talk to you about something called VOOT, and then finally Roland is going to teach you about the very latest in buzzwords, OpenID Connect. So with that, Francois, I think you should wear this, because if you stand next to the balloons, you won't.
How does it work?
You put it on like that.
Hello.
So turn on the
Hello.
And
does it work?
Clip it on. I'll give you like this one. It's 2 days.
Okay. Thank you. Welcome everyone. Must be quite early for you, also for me. I'm going to talk a little bit about OAuth and applications, all kind of applications, so mobile applications, desktop applications, and web applications, basically. So a little bit about me. I work for Surfnet, as was already mentioned. I work in the middleware department, where we work on all kinds of interesting stuff. One of my tasks is to work on SurfConnect and all kinds of technologies that are used in SurfConnect. Okay, so first some definition about what an application is, or what I consider to be an application. Maybe the audience has some opinion on that as well, so just let me know if you don't agree with what I say here. Well, to me, an application is basically any application that contains some state and can modify some state. So just a simple website is, for me, not really an application. But as soon as you can upload something or modify something on the server, then I consider it an application. And that is exactly where OAuth plays a role. So as soon as you want to modify something, or maybe access some protected content that is not publicly available, then you would start to be able to use OAuth to access that data. So if any of you have another definition or something better, tell me. Okay, so now something about the difference between authentication and authorization. It's, well, most people have, I don't know, most people in this room probably not, but it seems to be always a problem to distinguish the two. So just very short, authentication is figuring out who you are dealing with, and authorization is figuring out what the person that you identified during the authentication stage is actually able to do. So that's just a very short definition of those terms. So who is not familiar with the concept of OAuth or OAuth 1, as is already deployed? Okay, 1. Okay, then I'll just talk a little bit about it. So what OAuth is, or OAuth 1 basically, is that if you have 2 websites that want to exchange data. So for example, Facebook wants to use your Gmail address book to figure out your contacts and then see who else is on Facebook. So in order to do that, you could give Facebook your Google password, but that's not really a clean solution, because then Facebook can pretend to be you and do everything that you're able to do. So why would you want to use OAuth? Well, it means that you won't have to give away your password to anyone, and be able to give them a limited access token to access your data, that you can also retract the consent at any time. So Facebook can, for example, download your address book once, and then the token expires and it can no longer pretend to be you or access any of your data in your Google address book. So OAuth 1 was typically used for server-to-server data exchange, where applications running on web servers exchange data. And well, there were some attempts to also use that for applications that run on the user's device. But those were a little bit of a hack, basically, to get that working. So OAuth 2 is that, plus some profiles to deal with applications that run in your browser or on your mobile device or on your desktop even, to be able to also authorize applications to act on behalf of you and not just websites. So some terminology. If you're familiar with OAuth 1, then you probably know the terminology in the left column, like consumer, service provider, user, and all that kind of stuff. In OAuth 2, they were renamed to client, authorization server, and the terms on the same level are basically what replaced the previous term. So if you know what it was in OAuth 1, you can now see how it's called in OAuth 2. And during the rest of the presentation, I'll just use the OAuth 2 terminology, because that's somewhat more clean, in my opinion, and more clear of what is actually meant. In OAuth 1, there were two like profiles you could use to protect resources. One is called two-legged OAuth, and the other one is called three-legged OAuth, of which the difference is that in two-legged OAuth is granting an application or a website all access to all the data of the servers, and usually it was unscoped. So in addition to some credentials, the service needs to use some way to specify what resources it wants to obtain. In OAuth 2, that is basically there's a whole redesign of the available profiles, and I'll talk a little bit about the different profiles in OAuth 2 that will make more clear what is actually possible with OAuth 2. So this is some of this I already mentioned, but one of the main differences is that in OAuth 1 you need to do very complex signatures over the requests you are sending to the server, and in OAuth 2 that is no longer the case. You just use an authorization header to specify some bearer token, and with that you can access data or modify data on the server. Also TLS or SSL is required now. So to avoid leaking of any secrets. And before in OAuth 1 you didn't really need to use SSL or TLS because the secret was never passed over the wire, so it would be anyone else would be unable to steal the secret. They would only see the signature. Another big new thing is that there is a new profile in OAuth 2 in which you can do user agent based applications. Which means that the application is running in the browser completely. So there is no, basically no server-side application. It's only in JavaScript, HTML, and CSS, and it uses some REST APIs that are exposed and protected with OAuth. So you don't have to do anything else on the server side than provide a REST API, basically, which makes it more easy for server-side programming, that you don't have to deal with HTML and that kind of stuff. So the first profile in OAuth 2 I want to talk about is the web application profile, which is exactly the same as in the OAuth 1 case. So applications running on a web server. It's considered to be a confidential client in that the consumer or the client has a secret that can be used to log into the authorization server to exchange an authorization code for an access token. The flow will become more clear in a later slide. So this is basically three-legged OAuth 1. Now this is the user agent-based application that I talked a little bit about before. It's considered a public client. It does not have any secrets, and the way the application is identified is by a client ID and a redirect URL. That's necessary to avoid giving access to your data to any kind of application. So there's nothing really like this in OAuth 1. It's a new way of creating applications. And then there's native applications profile. That's an application that runs on your mobile device or on some desktop operating system. And it's considered possible for the user to extract the access token, so it needs to deal with that, and that's a possibility that the user can access that. This kind of applications were already possible with OAuth 1, but using some kind of a hack to store a secret in the binary, and then well, it's not really safe because users can extract this eventually and create their own clients anyway. So now on to some geeky stuff to show how easy it is to create an OAuth 2 client compared to OAuth 1, where you have to do all this difficult signature stuff. You don't have to do that here. So the top one is for user agent-based application that runs in your browser. You just have to redirect the user to the authorized endpoint with a few parameters that are, well, most of them are, well, easy. You just have a client ID which you registered at the server, and some redirect URL, which is the URL of your own application, basically. That runs in the browser. And for web applications, the request is basically the same. Just the only difference is the response type, where in the user agent-based application it's token, and in the other one it's code. So once you redirect to this authorization endpoint, you'll, as a user, you'll have to consent this request for access to your data. So you would probably get a dialog or something like this, in which you can agree to give consent to the application. So this is the kind of information that you could be able to modify. You can see the requested permissions there that you can, well, as the user, you can say, okay, but I don't want you to have read access, or I don't want you to be able to extract my user information. And then you could remove the permissions, although then the application might stop working. Yeah, to see if it's all trusted, you would have to look at the redirect URL to see where it goes. So this would all have to be pre-registered, and then you can be sure that it actually goes to this URL. So if you approve the application, you can receive the access token in the first case. In the user agent-based application, you just receive the access token that you can then use to access the REST API. In the other profile, you get a temporary authorization code, which is basically like the request token in OAuth 1, that you have to then exchange for an access token. So the top profile, you immediately get the access token, and the other profile, you have to still exchange it for an access token, a temporary code. So if you have a user agent-based application, it's very easy to extract the access token using JavaScript, because the access token is part of the window location hash variable. So if you do that, it becomes, you just extract it and use it. So how does an OAuth request look like if you have this access token? At the top you see the request URL of where you would get the data. And in the authorization header, the second arrow from the top, you see that there is a bearer token with some secret behind it, with which the server can verify that you're actually allowed to access this data. And this is in the user agent-based application. So once you perform this request, you get a response, which is in this case just a simple JSON object that you can then use JavaScript to parse and show something meaningful to the user. And that's just a very simple REST API to protect it with OAuth. So the other profile with the native application and web application, you have to still exchange the authorization code for the access token, which is done by sending a request to a token endpoint on the OAuth server and providing a pre-registered username passwords using, well, basic authentication. That's at least one of the things that are mentioned in the specification, that you can protect the token endpoint using basic authentication. So then in the post body of this message, you just put the code and you'll get back the access token in also, well, just using a JSON object that you can then just use in your application. And from here on, the flow will be exactly the same as from the user agent-based application. Only you won't be performing this call from the browser, but from your application. So if you would use curl, you can just request a resource using this command line as an example. So one of the problems with native applications is that you have to deal with the redirect URL of that was registered at the OAuth server. So you need to be able to tell to the application what the access token is, or the authorization code, basically. And in order to do that on a mobile, you could register some URL schema, like my scheme, for example, and then the application would register the scheme, and as soon as your web browser redirects to this my scheme URL, the application would launch and it would be able to receive the authorization code and then by itself exchange it for the access token, like in the previous slide. On the desktop, there is a bit of a problem due to the availability of a lot of browsers. So one of the solutions there would be to either register some scheme like in the mobile situation, but then for the default system browser. But as there are lots of browsers, it's a bit hard to do this correctly and make sure that it always works. So one of the dirty hacks you could do is run a service on localhost that receives the token and gives it to the application. Or the application could even launch a service himself and wait for the code to arrive. So this is a bit of a controversial solution. It's a dirty hack, but it might work. I didn't actually build this yet, but I can imagine it works. So again, this application would then use the back channel to request the access token from the authorization code. So one of the, well, some benefits of OAuth, it's a separation of authentication and authorization, basically, where the application that uses OAuth doesn't really have to deal with authentication anymore. It can just use the OAuth server to do that. So it just needs to accept and verify the bearer token it receives from the application, which makes it somewhat simpler. Which also means that OAuth can use any kind of authentication mechanism that already exists, like SAML or username password, OpenID, browser ID, any of those can just be plugged into the authorization server. And another advantage is that if you have a REST API that you're exposed to your to the internet, anyone can create an application and use it in a secure way. So now onto some new developments recently. One of them is then the user agent-based applications that was already pioneered with OpenSocial gadgets that just use JavaScript and HTML and CSS. But the problem with this was that it needed a container to retrieve resources on the internet because of some protection in browsers that don't allow it to access REST APIs cross-domain. So it would only be possible to access the resources on the server that the web application is coming from. And Yeah, another new development is now that it was considered possible to use native applications now with OAuth without resorting to hacks. Some new developments on the web that are kind of interesting. Mozilla's VOOT to Gecko, that's basically writing mobile applications in HTML, CSS, and JavaScript. And so all user-facing components are basically websites. So there is no native applications anymore. Take the Android core and put a browser on top, and that's all, basically. W3C has some specifications to make it possible to talk to devices on your mobile phone, which used to be a problem, or well, it still is, but they're working on that, to make it possible to access your GPS or camera or phone dialer from a web application, which is quite interesting, I think. Another interesting technology is unhosted. There was already a BOF on this and a lightning talk earlier this week. And that's basically about bringing your own storage. So separating the application from the storage, where the application is something that runs only in your browser. And by using OAuth protected storage server, you can access the data and bring it all together in the browser without the data ever being sent to the server providing the application. So, interesting if you use this user agent based application is that it's no longer needed to do server-side development except provide REST APIs. Once you do that, it will be possible for anyone to create any kind of application. Yeah, that's basically it. There's some more detailed information here that talk about VOOT, but that will be the next presentation. So these are some kind of recommendations if you develop a new application or have someone develop it for you, that these are some of the things that would be nice to request as for a technical implementation, to use to expose REST APIs and create your application using the same REST API, protected by OAuth if necessary. So that makes it possible to create all kinds of applications, and well, as long as you use your own API, then you're sure that it will all work correctly and make it very easy to extend and use the data from other applications, or use multiple REST APIs from different locations to create some kind of mashup, and give you the freedom to modify the user-facing application without modifying the underlying server-side code. So, and now the conclusion. It's a bit of a controversial conclusion, so I hope some people won't agree with this and tell me that it's all wrong. So, my statement is that the future of all application development is these user agent-based applications that are just written in HTML, JavaScript, and CSS using REST APIs. So, if you have some comments on that, let me know. Or if you have some questions, remarks, or don't agree with something else, or I didn't explain something well enough, just ask a question.
Unhosted manifesto. I'm sure there's somebody out there who's written some server side. Okay. Oh, Chris has written server side.
Wow.
So where do you see SAML the role of the federation operator if it's all about OAuth 2 and the HTML5? The unhosted app?
Well, you still have to do some authentication. So, and as soon as the SAML infrastructure is already deployed, you can just plug it in and use that. So, SAML won't go away immediately, but maybe eventually. But we'll hear about OpenID Connect, so maybe that will.
So what about attributes and schema?
Sorry, what about?
Attributes and schema and the kind of things that SAML provides some basis for.
Well, that can all still be used.
Okay. Thank you.
Okay.
Anyone else? In that case, I think thank you, Francois. And moves to the group. Andreas will talk to us about the science of groups.
So, hi, my name is Andreas Solberg from UNINET, the Norwegian National Research Network. I'm going to talk to you about something called VOOT. It's short for Virtual Organization Orthogonal Technology. Just a name that we use so far. This is research work from Identity Federation, part of the GIANT program. So, let me start to describe a scenario so you know what the problem is before I present a potential solution to it. So, you work in a dynamic project collaboration group. I guess most of you probably do because you collaborate with others across entrants. Have examples, you can say like a Terena working group. And you would like to use web-based services to collaborate. And to do that, you probably would like to set up some collaboration space across multiple services, and you would like to set up access control. You would like to put the users into the same group somehow, and give them access and make the content available to them. So, you go to this service, Foodle, to set up a group there. Here is the group interface for managing your group. You add the name, you add some users, members to the group. Then you go to another service, just to give some examples. OpenWiki to collaborate on notes and documents. You have to set up the access control and the group memberships again. You have to do the same thing twice, and you would like to use a mailing list, so you do it once again. You add all the members as member to the mailing list using cool software like Simpa for that. Then you would like to share some document using Liferay, and you have to set up the group again. Then you would like to do some video conference because you are in different country and you would like to use like OpenID Connect for that. You set up the group yet another time. So I guess you agree that this is not what we would like the end user to experience. And it gets worse because if you have a group, groups can be dynamic, so you will have a new member in your collaboration group that you would like to add, and you will have to do that for all the services. You would like to remove a user, and you will have to do that everywhere. And it will be a mess to maintain this. So this is unacceptable. I think you all agree. We should not accept that we will have our end user have this experience when they are using our services. So that's where VOOT comes in. In Identity Federations, we have a vision where we will try to make some solution to this. It's not really simple, but we make an attempt to set up a framework or a solution where you can set up the project group just once, and you can use it everywhere, and you can do dynamic changes to the group, and it will be reflected on all the collaboration services that you're using. So that's pretty neat. To be able to solve our vision, we started out with a few use cases. We would not like to solve all the world problem related to groups, because then we probably will never be done. So we have tried to focus on what a few use cases that we will think would cover a lot of the situations for our end users for our typical services. So we'll cover a use case dealing with access control, which is probably a very common use case. You would like to use a collaboration service and set up a group and give access to the members of the group. But we have a few other use cases as well. Invitation of new users. You are sharing a document, you would like to push it out to all the persons that you collaborate with. So maybe even the content is public already, so you're not using it for access control, but you would like to kind of push it and make it associated with a few individuals, member of a collaboration group that you would like to send it to. Then we have mailing list server. So we have, first use case, to be able to solve this, we would be able to, use cases like the end user is going to the service. The first thing that the user would like to do is to create the content and associate access control with references to all the members of a group that is hosted remotely. So first, the user would need to see to do the user interface to be able to set up the access control. It would need to list all relevant groups from remote locations to to tell the service who is going to access these resources. So that's the first phase. The second phase is when some of these users is actually trying to access the resource. It would need to get the list of all the groups that the current user is member of in order to perform the access control decision. Another use case that we are dealing with is about invitation. So a user creates a resource and would like to invite or notify a set of users. The service would then need to retrieve the list of groups, so you can choose one. And then afterward, it would need to get the members of a group with the necessary contact details in order to send them a notification. The last use case is a bit different because it doesn't necessarily have to involve the end user. A mailing list is kind of running server-side. And if you would like to associate a mailing list with a collaboration group, you will have to allow a mailing list server to be able to obtain all the members of a group from a remote location. So this solution we can also apply for some of the legacy software that we should be able to deal with, although we don't really like it. So in order to do this communication between services, between services and what we call the VOOT provider, which will be entities that are authoritative of group contents and group members. We need something, a trusted layer of being able to communicate between these entities. And what can we use? We use OAuth 2.0, which you have already been lucky to be introduced to by Francois. And it's perfect for this purpose of communication between services. What's also interesting is that the layer of trusted communication between services I would consider orthogonal to the federations. So as Chris asked about where does SAML fit in, well, it still sits there for authentication, but we add another layer for communication between services. So all these services, when they would first like to authenticate using the SAML federation, and then they can communicate. All the delegation, things like that is handled between the services. So this is the solution that we will see first. to be able to extend communication just between the service provider and the IDP to also allow the services to start communicate with each other. What is good about orthogonality is that it means that to be able to facilitate communication between your services, you don't really have to add new functionality into your proven to work existing stable federation. You don't have to add new features to your IDP. You can use it as it is, which we consider a benefit because these federations are starting to get stable. Another property of OAuth is that when you are communicating from a service to a provider, you do typically both authenticate both here and here with your provider, and it means that all have the current user implicitly referenced to some local or to some identifier, some understanding of who is the user, and it means that you don't have to share any user identifier in the protocol where you communicate. And that's a property that we like because we do not really want to require a common unique identifier that is shared across all services for a lot of reasons, including privacy. So what's nice about using OAuth as an underlying protocol for doing group data exchange is that it's generic, so it's not only used for groups, because you would like to have a lot of other things as well. You would like to maybe share contact data, other kind of application-specific data, calendars, a lot of things, common information objects that are relevant to a lot of your services. So, what is almost a completed standardization phase in ITF is something like draft 25 or something, so it's ready to be deployed. And it's the base layer of a lot of new emerging protocols that we consider making use of, like OpenSocial, Scheme, OpenID Connect, etc. It's used by a lot of social applications, social services. You know, the big companies are relying on OAuth. It's targeted to be really, really simple for the consumer to implement, which comes from the commercial world where there is just one provider and then millions of consumers. But still it fits into our use case as well, because we would like consumers to be able to integrate easily. And it supports, as Francois has told you, different flows depending on the type of application. And it's very flexible. You have scopes that you can associate with nearly anything, not only groups. So one thing that we would like with this VOOT project, we would like to not solve all use cases, but one thing that we really would like is it to be able to cross national borders, because these groups doesn't need to necessarily be within a single federation. So we have the use cases and we have the underlying base layer of OAuth. Then we will need to kind of define a kind of abstract protocol, what kind of data information object and what kind of protocol element we would like to use. We would like to be able to retrieve all members of a specific group. We would like to get a list of groups of the current user. And notice that there is no user ID included in the request, because it's a kind of implicit reference to the current user. And we would like to get all groups that are relevant that the user can access. There is typically two information objects that needs to be shared. Is list of persons, list of members of a group, and there is a list of groups. So that's the objects that we are working with. So then it's starting to get a bit difficult, because then we will need to decide exactly how to do the protocol itself. And we would like to reuse an existing protocol, or we consider at least using an existing protocol. And we have more or less decided to use OpenSocial, at least for the prototyping, OpenSocial 2.0. There is a new emerging standard scheme for cloud provisioning of user data that we also recently have considered, because it has some properties that we would like, and it looks promising, but still also lacking some features that we really would like, so we maybe would have to add some features to it. Also, I think our use cases are so simple that, or the protocol element, so doing an independent protocol from scratch is also kind of a possible approach. We, as I said, have decided to use OpenSocial for now, but we are not entirely sure that we would like that to be the only approach in the future, because OpenSocial is likely going to die slowly. Which means that it will be a bit not good to only be able to rely on it. So here's an explicit protocol mapping to OpenSocial. What's really nice about OpenSocial that it has built in the support of implicit references to the current user using the @me syntax. We haven't seen that in all the protocols, although it should have been there. It looks like this. It's really simple, based on JSON and OAuth beneath the protocol. You have get my groups, get group members of a group ID. Okay. This is probably, yeah. So what have we done so far? We have done some work on proof of concept. We have a service called VOOT that I've been working with, that we have implemented, the OpenSocial profile of VOOT. We have other project, web app engine, that I've also done integration with. Surf Connect is been heavily involved in doing testing. Sunat and Simpa from Granatier is also involved. So we have done some implementation in all of this, and we have done integration testing. And then OAuth has kind of migrated from version 1 to 2.0, so we are now soon completed with migrating everything to OAuth 2, and we look forward to do more integration testing using OAuth 2, I guess, this summer. Here is some screenshots from the proof of concept work. Here is from Simpa, which is kind of adding VOOT support into its core implementation. So you'll be able to set up a new mailing list referring to a VOOT-defined group elsewhere. Here is some of the user interface in Foodle, where you can see the process of setting up the initial connection between the service and providers of groups. Here you see a complete implementation where you have referred a remote group along with internal groups in the Foodle application. And here you see this is actually a group space, it's a project space for a group that doesn't really exist in Foodle. So it doesn't know the group members, it doesn't know documents that share, upcoming, anything. It's getting everything from the remote location. So there's a lot of, although we have something that's, I would say, promising and solves a lot of make it easier for the user. We still have some challenges that we are working on these days. And one of them is agreeing upon exactly how to map into the protocol. Another is how to deal with user experience, user interface for the whole process, connecting, because you first have to, OAuth has to do an initial connection where the user had to accept that you are actually allowed to retrieve your group in one service from the group provider. And then existing services are often not very well suited to do this kind of deep integration to add group being referenced from elsewhere. So it's easier for a new application built from scratch, but it's more difficult with applications that are the older application, the more complex, and large applications also can be very complex to modify. So this is what we are dealing with currently. When we have solved this, we still have some challenges to work on in the future. Okay, and it has to do with discovery and scalability, because when you are having a lot of providers, you have to know when to connect to which provider. And when there's a lot of providers also, you will need to have a scalable trust layer combined with the OAuth layer, which is something that OAuth do not provide yet, but we will probably work on making that. Not only for groups, not only for service-to-service communication, but for OpenID Connect, which you're going to hear more about from Roland very soon. So is there any questions?
I saw hands being raised.
There's one thing that I'm slightly uncomfortable with looking at those, let's say, function calls that you have in the protocol. It is that as a user, I would not necessarily want a service to be able to retrieve the list of all groups I'm in. I would much rather give consent that the service queries whether I am a member of a particular group, not just giving all information that maybe I'm working on Project Tor or whatever. Yeah.
Yeah, I think that's a good point. You would like to reduce or limit the list that is shown, but I would. It would mean more work for the user to really make decisions on exactly what is going to be shared. So what we have already is that nothing will be shared with other services unless the user really accepts it. And then the user has to be told exactly what is going to be shared, which kind of groups. So some of the problem with trying to limit out the possibility of getting the whole list of groups you're a member of is that typically one of the most common use cases is that you would like to set up access control and you would like to kind of check off these are the groups that are going to have access, and then it will be inconvenient to not be able to list the groups that you are a member of in the application. So
you must have the ability to type in some sort of globally unique identifier for the group and remember that.
Yeah, so it has to do with usability and having a compromise, but I understand the concern. And I think that probably the solution would be something like a compromise where you would not consider all your groups to be shared across services. If you have some groups that are really private, you maybe would like to not share it across all services, but then keep it only for a specific service. Yeah.
Actually, you already said it, but I was going to suggest that this is actually an implementation on the group provider side, where you should limit the the stuff that a remote party can request. That's actually what we implemented, for example, in Surf Connect to do exactly that.
Yeah.
Could you have the group selection being done by the VOOT provider, just like discovery services are provided by the federation operator? So a user would just select a group, not in the application, but in the VOOT provider interface.
It's definitely possible to do that kind of integration where you send the user back and forth or integrate it in a secure iframe, something like that. But still, some of the main problem you will run into then will be the problem that you will not have only one provider. You will have maybe 5 or 10 providers, and you would like to mix groups between some of them, and then it will be rare. It will be weird to send the user off to some provider, and then, yeah, it wouldn't really work very well unless. Yeah, but still, these kind of things are very interesting to think more about and see how it will work. And I think the best approach will be actually to design something simple, like we have with VOOT, which will work somehow with a lot of use cases. But then you will see limitations as well. You will see needs for doing improvements, and then probably we'll try to do use cases building on top of that. And there is some flexibility into the current approach with VOOT, because you could do things like was already mentioned by Niels, that to have more control over the provider, you can do like the provider is deciding exactly what is going to be shared. You can also build other things that would go on top of VOOT. That would allow you to keep the same base layer simple protocol, but still make it more advanced use cases on top of that. Yeah. Probably we'll think more of things like that in the future, but we'll have to keep it simple for the beginning.
Agreed. Thanks.
Time for Roland to step up to the mic and sort of wrap this all up with an exposition on the next cool, new, shiny, bright thing, OpenID Connect, which, as we'll probably learn soon, has about as much relationship to OpenID as that swan has to an elephant. Thank you, Roland.
On the way to the bright future. So, yeah, okay. Roland Hedberg, you probably know me. The reason I can confidently talk about OpenID Connect is that I'm doing, together with Andreas, a test tool for OpenID Connect. And some of you may have heard about that, which in essence means that I do the reference implementation in OpenID Connect. A pretty interesting situation. I actually get calls from Google, IBM, and Microsoft, and Facebook, and such, sort of asking about sort of the standard, what it says, and so forth, and how it should be interpreted. Very interesting. You see the politics when it comes to these kind of things. So anyway, just to make a short comparison to where OpenID come from. OpenID Connect is sort of a way to bridge OpenID OAuth, but do it in a sort of a better way, sort of using the knowledge that we have gained from running, for instance, SAML federations and doing that kind of things. So anyway, OpenID, what it did was this kind of thing, authentication. You wanted to use some kind of service, or in this case represented by Eve, you're Alice. So Eve says, who are you? And then you go to some provider, Notary in this case, Google, and who then gets your information, your identity. It signs it and says this is true as far as we know, this is true. Which in Google case means that, well, the user has entered this information. And that's it. But anyway, Google stamps it on there, it's information about the user. And then you can pass this on to the service, even in this case. OAuth has also been used for identification. So today, if you go to a web page and it says, do you want to log in using Facebook, for instance, you will, in essence, use OAuth. You won't use OpenID. So what you do then with OAuth is, of course, OAuth doesn't give you the user information. It gives you a key, a token, which is also used as a name for this, which then the service can use to get your information. But the service then has this key, so it can use that as long as it's valid to get any type of information. So it could be, of course, information about you, but the basics is that it's some resource that you control. So OpenID Connect then does both of these things. So it actually provides you with a key, you as the service, with a key to get that more information, but it also provides you with some information about the information in this case. So it's the things like when was this, the identity information, when was it created, when did you log in, to give your permission, and at what level of assurance is it, and all that kind of things. But also what OpenID Connect allows you to do is you can get a key ring, you can get lots of key. So you don't just get information from the identity provider that you're talking to, but you can also get keys so you can go to other identity providers and get more information about this entity, this person, or whatever it is. And this has been something that the commercial side really wanted. So that as a background. Now we stop looking at nice pictures. Those who know SAML will recognize this because it's similar. You have the user connects to a client, is then redirected to something to do the authentication. In this case, it's the authorization server is separated from the authentication server, which means that and the authorization server is part of OpenID Connect. The authentication server isn't. And that is also the same as Francois was talking about earlier. So it's not part of OAuth either, so the authentication server could be anything. So you do authentication, you get back to authorization server, and then you have a communication about which kind of resources should this client, the RP. Again, you have this confusion about abbreviations and names of things. What the RPs, what kind of information they should be able to access. You get back a referral again to the client. If you're using authorization grant flow, which means that you just get an access authorization grant, you don't get the token. Then you'd have to do the next step is that you go from the client to the authorization server. The client has to authenticate against the authorization server, and providing the access grant, it will get back an access token. And then it can use that to get the information from the resource or from the user info endpoint. So what's added here when you compare OpenID Connect and OAuth is actually these two things: user info endpoint and the session endpoint. And the session endpoint is then supposed to be used for single logout, for instance. That kind of thing. Managing the session that you're in. You can also use sort of simpler, the implicit version of Flow, where you get the access token directly. But we skipped that so far. So I thought I would go through sort of a day in a life or a flow. What happens sort of when you want to get at some kind of information? Well, what you start with is that you have this wave problem in SAML. In OpenID Connect, what you do is that the user provides an identifier, which in most cases may be an email address. Using that identifier, you try to find the information about which OpenID provider should I use. And in this case, we started off by wanting to use something called a simple web discovery protocol. But there's been a lot of discussion about that lately, and we are now moving to using WebFinger instead. And it's all based on sort of what the trusted DNS gives you. So you get this email address, and you have the domain name part of that, and you go to that domain, and you add .wellknown/hostmeta.jso. JSO means that you will get JSON. If you don't do that, you will get XML. I mean, you will regret that for your rest of life. So anyway, if you do that, say JSON, you will get back lists. Oh, I lost. Oh, get it again. Which will say that this is about an OpenID Connect issuer, so you know that's the right service that you're after. And then you will get the URL to that OpenID provider. To use that address, I switch addresses all the time, so don't look at the specific sort of URLs. But you go to that address, again you add .wellknown, and then you have another thing, which is OpenID configuration. And you get back another JSON packet, which gives you all the information you need about the OpenID provider. You get all the endpoints, the registration endpoint, the user info endpoint, token endpoint, authorization endpoint, and so forth. You also got the information about sort of what this provider can do, what it supports, and you get the link to the keys that this guy is going to use. And this is in a format which is new. So you have to be able to deal with that. It also tells you sort of the version it's running and the issuer, which is sort of also important. So there you have the information. Now the next thing is that you register. Your client register with the server. And you go to it and you tell it, okay, I'm this application. This is my name. This is my type. I'm a web application. The redirect URIs I'm going to use is these. And this can be a list. I only have one here, but it can be a list. And then the type says that, well, actually there are two types right now. The first is that I want to register, and the second is I want to change something in that I registered before. And this is client associate is I want to register. And then contact information. Who am I going to contact if something goes wrong? Or the server is going to contact on the client side. There are a bit more you can add, but that's sort of the basics. You post that, and then you get back a response, which give you... Sorry, I missed that. Where is that? There's a slide missing. Anyway, you get back a response that gives you the client ID, which you also see up there, and the client secret you're supposed to use. when talking to this server. That's sort of the basic, that's what you get back. So now you know the other side and you have registered, he knows who you are. Now you can start sort of asking him questions. And what you want to do then is do the authorization. So you send an authorization request. You tell him who you are by giving him the client ID. You give him a redirect URI, which then should match what you registered. And right now there is a big discussion on the list how much of it should match. Google has one interpretation of that. Everyone else has another interpretation. So we'll see what happens. You use the scope for telling sort of what kind of information am I eventually trying to get at. You have nonce and state, which is sort of, well, just on your side to know when you get a reply, this replied, in what connection did I send the request, sort of, so I can match it on my side. And then you have this blob, big blob, called a request. And what the heck is that? I'll get back to you. If you just make immediate comparison with the SAML authentication request, you can see some of the things are similar. You have sort of the ID, which is the same as nonce, you can say. It's the sort of state that you use to keep the session states. You have the information about the issuer. You have information about the redirect URI, and so forth. But there are lots of things missing that, of course, SAML has. There is nothing like protocol binding. We don't have issuer instance. We don't have anything about name ID or anything like that. So we're missing out on that. But there are big similarities between these two protocols. Yes, this big blob is what's called a JSON Web Token. And the JSON Web Token consists of three parts. It's the header, it's the second part, and the third part. And the header tells you how is this signed or encrypted, and which algorithm did I use for doing that. And if it's signed, which is by far sort of the most common thing, the second part is the payload that is signed, sort of, and it's the UTF version, and it's base64 encoded, so it shouldn't be messed with by the network. And then the third part, if it's signed, is the signature. So you know, and there is nothing like in the XML case where you have to do, damn, I just forgot the name. Canonization, precisely. Nothing like that, because you actually send the complete packet that you have signed. It's exactly the packet that you're going to sign. It's there. So, if you unpack this blob, this request blob, you will get this. The first part of it is the same as you had in the request. Response type, client ID, redirect, and so forth. So that's just sort of verifying that this is actually what I sent. But then there is information about, which is in SAML speak, sort of the attribute request. We are talking on the OpenID side, we're talking about claims. And I had a big time sort of wrapping my head around what claims was, but it's attributes and values. So here you can say that I really want name, given name, family name. It's optional if you give me nickname. And I can say that when I want this back, I want it signed. And that's the user info. The ID token, which was then sort of the metadata about the user info. There's a max age on that, and I want to use ACR, which is lower, sort of, but cryptographic sort of, no. But that's the same, so that's lower too. I get a response. In this case, it was the authorization grant flow, so I get back a code. I don't get any token. I get sort of the state and nonce that I had given when I sent the request. And then I get the ID token. Again, GWT. And if you unpack that, you will see the issuer of the information, the user ID, the audit. I mean, who is this intended for? When it will expire, again, the lower two that was sort of really used, the nonce that was in the original question, and when the authentication took place. So that's the metadata about the user information. There are some, if you're using an implicit flow, so you will get the token together with the ID token, there will be a part here which is the hash of the token. So you can verify that the token actually was sort of the same. No one messed with the token on the way. You can by having a sort of a hashed version here in the sign part. And the next, first, of course, is getting at the user info request. So you have the user info endpoint, and then you sort of the access code, the token you got, you send that, and then you can specify the schema. And right now, there's only one schema, that's OpenID. There's been talking about having SCIM as a schema, but I would say that presently, sort of, they're concentrating on getting the protocol right and not so much sort of what actually should be sent as the user information. And then you get user information back, and it's the typical attribute value pairs. You can, sort of similar to LDAP, attribute options, you have this hash sign, which then, and you can add sort of the language that is used. The first time I saw this, I said, well, this is not going to work, because there is no namespaces, where is the possibility of extending this and so forth. And I got pushed back sort of when saying, well, we'll deal with that eventually. So that was... As you may remember from earlier, sort of I talked about sort of possibility of having aggregated and distributed claims, and one of the things you can do in OpenID Connect is that so you have an identity source, and the identity source may get sort of information from some other identity source, and package that when it returns the information about the user. And you do it like this. You can say that I have some extra information, and claim names that extra information. Those attributes came from this source then. And I just made an abbreviation here. If it's distributed, you will sort of similar, but in this case, you will get the endpoint. So you have to go the information is at the other information source, but that information source is not sort of giving that information to the identity source, but wants you to go there and fetch it. And the reason for this is economics. The information source that has like information about payment info, shipping address and that kind, they may want to get paid for providing you with that information, or they may want to do some extra checking sort of before you get at it, to make sure that you're really allowed to see it. When you also together with the endpoint, you may get something like an access token, which would then allow you to get at the information. Comparing OpenID Connect to SAML is tricky business. I would concur with previous speakers saying that it's much more easy to implement. I've implemented both. I'm probably one of the few persons on Earth that have done that. So I can definitely say it's easier to implement, especially the client side. Using JSON instead of XML is made some things simpler. Definitely sort of this signature encryption thing is actually working. There's always this sort of problem when it comes to XML. It might work, it might not work, and you never know why. And that has also to do with canonization. I would say that delegated claims is sort of an added benefit. There is sort of one thing, though, which is missing in OpenID Connect, which you have in SAML, and that is to allow the client in this side to go to another. In SAML, you can go to an attribute source and do an attribute request using sort of provided that you have an identifier for the user, which is the same that you got from the IDP as will be at the authorization, the attribute authority. That functionality isn't in existence in OpenID Connect. Either the IDP, if you call it, has to collect all the information, or it will provide you with links to where you can find more information. There is no opening for sort of turning around with an identifier and go to someone else and say, I want more information about this person. There is no SOAP or POAS in OpenID Connect, which is also good, I think. Some may not like sort of the service discovery dynamic client registration. I like it. It actually makes it very neat that you can sort of from a user get sort of something that looks like an email address, and that's the only thing you need. You can then find sort of the OpenID provider, you can register, and then you can start the communication. Of course, the people that don't like this usually sort of say that, well, the server doesn't know anything about the client. How can it sort of trust the client in this case? There is nothing. If someone out of the blue comes and register, why would you give that sort of information about the user? But there are ways around that. There is no metadata presently. There is no sort of opening for collecting metadata about OpenID providers in some way, so you can sort of fetch it, or for that matter, of clients. And as I said, there is a very limited identity attribute set for the time being. That's probably going to change. It has to change, I guess. So if you were like to have the possibility to add another scheme where the scheme would cover like groups and such, you could see sort of easily that VOOT would use sort of OpenID Connect for that kind of stuff instead of using OAuth, which is a true subset of OpenID Connect, of course. The status right now, their implementation in several languages, and they are increasing every day. There is ongoing the interoperability testing. And mine and Andreas' conformance test web service is, I would say, sort of in operation. There are lots of people using it. And we have gotten very positive feedback on it. People are likely very pleased with it. That's very nice. Is Niels here? Yeah. I added this after your question yesterday. So, as Andreas told you yesterday, so when we divided the work on sort of the test suite, yes, we divided in such way. I did all the sort of OpenID protocol communication, and he did all this fancy GUI stuff, really good stuff. And we made the division between us such that my stuff can be run as a script from the command line. So, and that is what he does from his part. He just runs my script at the command line as if it was running from the command line, and then it gathers this sort of standard out, standard error, and I sort of send different streams to these two. That means that you can actually run this stuff from the script, from the command line directly. So in this case, I just run eBay, their implementation, and I run a specific test. And then I can see, you go through the discovery, it worked, you go to the registration, it worked, and then you do the authorization request, and you get all this information about what was sent, what was received, and all that kind of stuff. This is a specific test. You can also do sort of the complete thing. Just go through all the tests. This is just 40 of them. There are more than that. And this means that I got that feedback from the developers that they have integrated this in their unit test suite. So when they're unit testing their stuff, they're using my stuff as one of their sort of thing that they're checking with. And I'm very pleased with that. That means I actually succeeded, I would say. And I think that was it. Yeah. Questions?
Niels, I think.
Niels! How surprising.
What does an endpoint for a delegated claim need to implement? Does it implement exactly the same stack as an authentication identifier endpoint implements, or?
It has to implement a user info endpoint, yeah.
Okay.
It does.
And how does the claims endpoint handle authentication? Does it assume somebody else will do the authentication, or can it do its own?
It can do its own. Or you can just say that if this guy presented me with a token, you have this access token stuff. Oh, sorry. If he presented with access, this is a very simple token. In reality, this would be something that would be signed or something like that by the claims provider. So you could really check, did this come from me? And if it came from me through a sort of trusted source, which is the identity source over there, then I will give you the information. And that's the authentication I need. Sort of.
So actually that's a really good case for introducing SSO, because otherwise it would mean, or potentially mean, that if you go off and fetch info at 5 endpoints, you would need to log in 5 times as a user. Okay.
Roland, you mentioned that they haven't gotten around to doing namespaces yet. Is that because they haven't thought about namespaces, or is it part of the big move we're seeing from hierarchically tagged and relational databases to flat tag space? For example, if you look at the Google contacts, you can fill in the name and the phone numbers, and they don't kill you if you add in a +47 for Norway in a phone number, whereas an LDAP server will happily kill you and sell your soul if you do something so evil. So is that part of a trend, or is it just not done yet?
That's a very good question. I'm not sure I can answer it. But to my understanding, the reason why they had this very simplistic identity attribute set was that they looked at what's out there at the big social services. So what do Google, what do Facebook do? And we take one of those, and in this case it was the Facebook Connect stuff right off, and they didn't think more about it than that. Lucas.
Well, actually, it's 2 questions. So,
you only get one. No.
One weak spot of SAML federations as they are deployed today is the lack of easy support for non-browser applications. So if you don't want to implement the full web browser, it's difficult to create a terminal application that does a complete SAML login. And if I understood this correctly, this should be fairly easy with OpenID Connect, right? Because, yeah, that's what you showed. And
exactly that, yeah.
So you would agree that it's very well suited for non-browser apps then?
Absolutely.
Okay, then second question. You said that compared to SAML there is metadata missing. Do you still think that OpenID Connect could at some point replace SAML federations, although this missing piece?
Oh, I don't think that's a stumbling block. I don't think that sort of will actually affect the outcome of this, if you call it war between SAML and OpenID Connect. I think that for a long time we will have OpenID Connect and SAML side by side. And I envisage that sort of presently you have your IDPs and they have endpoints which are SAML. And eventually sort of the Shibboleth IDP will have another endpoint which is OpenID Connect. And you can use exactly the same background. You will use your LDAP directory, whatever you have in the background, to supply the information with. The endpoint will just speak instead of OpenID Connect instead of SAML. That's one transition way that I see sort of before us. It's also easy sort of on the client side to do the similar. So you will have sort of when you do the wave stuff, sort of if people enter in sort of an email address like thing, and you find that you actually find an OpenID Connect server managing that, you will use that. Otherwise, you will use Disco use sort of thinking that it's probably a SAML IDP over there. So that's, as I see it, a transition. Eventually, sort of, one of these two may go away, and in that case, sort of, I'm fairly sure of who is going away and who is going to remain.
And it's fair to say, though, that metadata for OpenID Connect is probably not that far away into the future. There are people already working on it.
Right, but on the other side, since you have sort of, if you were able to fix sort of the perceived problems with dynamic registry and dynamic sort of lookup of information of servers, then you wouldn't need metadata.
Well, right, you won't need the metadata for endpoints, but you still need it for finding. Well, first of all, you need it for discovery information, because that something needs to drive the disk use interfaces. But you also need it probably for finding the keys, so you can trust talking to that, because it's a whitelist problem.
Keys is the big problem.
Anyway, I'm actually going to cut it there because we are at time.